notice, and this is the typical copyright. Please note, Section 4, Measurement, Objective 4.10, Calculate surface area of solids. The syllabus goes on to specify what solids: prisms, including cubes and cylinders, right pyramids, including cones, and spheres. My original plan was to deal with all of these in one video. However, after the introduction and recording part 3, that's this part here, and 1, that's that part there, the video is already about 52 minutes long. So obviously, I need to split this objective into 2 videos so that this now becomes part A of objective 4.10, and of course the next video would be part B. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, Number Theory and Computation. All 33 of those videos have been published on YouTube in their entirety. Section 2, Consumer Arithmetic. All 12 of those videos have been published on YouTube in their entirety. Section 3, Sets. All 6 of these videos have been published on YouTube in their entirety. So that's a total of 51 from sections 1, 2, and 3. Please make good use of these. Now we are at measurement. This is the 11th of 16 videos, and I am somewhat behind schedule. Hopefully, January 2025, statistics, and then February 2025, algebra, March 2025, functions, relations, and graphs, April 2025, geometry and trigonometry, and finally, May 2025, vectors and matrices. Disclaimer: this schedule is just a projection which may or may not be fulfilled. It is not a contract with anyone. As pointed out already, from section 1, all 33 of these videos have been published on YouTube in their entirety. That's all 33 of these videos here. Especially since this section forms the foundation on which the rest of the syllabus is based. So please make sure you look at these 33 videos and know them well. Another reminder, you need to know the times tables from 2 to 12. Now, if you already know it, fine. If not, then you would have to learn them, especially since calculators are not allowed in paper 1. From section 2, as just stated, all 12 videos have been published in their entirety on YouTube. From section 3, all 6 videos have been published on YouTube in their entirety. We are now at section 4, measurement. We are at this point here. So video 1 and video 4 and video 9 from section 4 have been published on YouTube in their entirety. These others, video 2, 3, 5, 6, 7, 8, and 10 are only partially published on YouTube. So as I said, we are now here, objective 10 in section 4, calculate surface area of solids. This is video 11, and this will only be partially published on YouTube. So section 4, objective 10, calculate surface area of solids. Before we go on, recall I said previously that you will need a good math textbook or maybe a set of 2 to get more practice questions. CSEC recommends the following, shown at right, these here. And from that list, what I would recommend is a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. Here's volume 1, picture of volume 1, Mathematics, a complete course with CSEC, with CXC questions by Raymond Tulsi. And then this is volume 2. Another disclaimer, I get no financial or other benefits from the sale of these books. One other thing before we go on, very recently, late 2024, I think, a website with AI interactivity has been made available free of cost that deals with math CSEC pass questions only. Math CSEC pass questions. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you have a question that you need explained, you can ask AI assistant either by text or voice, and most likely that will be explained to you. This is the URL, RSC student, and the home page is shown on the next slide. So as I said, that is the URL. I will include the URL in the description of this video below. So all you would have to do is click on it and you will be redirected to that web page. This is the home page of that website. You register first, and subsequently to that, you sign in. This is a print screen of section 4. We have completed all 4 of these objectives from this page. And then from the next page, these 5 objectives, that would be 9 total. We are now here at objective 10, calculate surface area of solids. Now there are some explanatory notes here, as you can see. Prisms including cubes and cylinders, right pyramids including cones, and also the sphere. And you are given a formula here in the syllabus for the area of sphere. Now I want you to note carefully that in this formula table provided for the examination, you don't have any formula for area of sphere. As a matter of fact, you don't have any formula for area of solid objects, including the area of sphere. So you would have to learn that one. So this is the top part of the formula sheet. No formula for surface area given on this sheet, including surface area of sphere, 4 pi r squared. So you would need to learn that one. So let's make sure we understand what these solids look like. Prisms. A 3-dimensional solid object in which the 2 ends are identical and the sides joining them are rectangular. We're talking about regular prisms. So if you look at this box here, notice this side and that side there. Those are the 2 end sides that are identical, and they are joined by rectangular shapes, 4 of them to be specific. Here is another 3-dimensional solid object, which is a prism. In this case, it is a cube. This is a triangular prism, and this one is a cylinder, which technically is considered a prism. Pyramids, on the other hand, are also three-dimensional solid objects with one end as a polygon, and the opposite end, so to speak, is a point, and the sides joining them are triangles. So let's look at this. You have a pentagonal pyramid. This other one is a rectangular pyramid. You have a rectangle below there, only one rectangle, and you have a point up here, and the sides are triangular and slanting. And here is a cone. Notice a cone is included as a pyramid. And then, of course, you have the sphere. It is a three-dimensional object that is round in shape like a ball. So here is a sphere. Now, they talk about a right pyramid. What does a right mean? It means simply that if you drop a perpendicular from the apex here to the base, it will form a right angle with the base. And the same thing applies for this rectangular pyramid here. If you drop a perpendicular from the apex, from the top there to the base, it will form a right angle with the base. So these are called right pyramids. Secondly, what do we mean by surface area? We mean the sum of the faces, of all the faces of that solid shape. So this one here, for example, has 6 faces in pairs, opposite pairs. We would have to find the total area of that, and so on. So let's consider that same one. If this represents the base, it's a rectangle, this base down here. To the front here that we are looking at, that's the front face. At the top, you have that, and behind that, you have the back face, and then to the left here, you have this face, and to the right there, over on that right there, you have this. So what you see here are the 6 faces on a rectangular prism. For this cylinder here, if you cut off the top and the below, you will get a circle here below and a circle here, that's the top, and then you split this hollow cylinder and open it out, you will get a rectangle. So we have to find the area of these 3, add them together to get the surface area of a cylinder. So we'll begin with the easiest of these, the sphere. A sphere, as we said, is a 3-dimensional object that is round in shape like a ball, not a disc. So it was determined a long time ago that the surface area of a sphere can be calculated by using this formula, 4 pi r square. Remember, I said that is not on the formula sheet. It is in the syllabus, so we will need to learn it. So consider this sphere here. Example 1. Calculate the surface area of the sphere if its diameter is 28.0 centimeters. So we know the formula for the area of a sphere is 4 pi r square. We know that the radius is 14.0. Substitute in our formula. Surface area of a sphere is 4 times pi, which is 22/7, times the radius squared, and we get this answer. Now, I am not too sure if CSEC will accept that. We do have 3 significant figures here, and this has 4, but just to be sure, we will round off the 3 significant figures where that 6 is, which is the tens position, and you get 2,460. And since we are rounding off at the tens position, we take half of that position, which is 5, and that is our margin of error, or uncertainty. And that should suffice for spheres. All spheres, to find the surface area, you apply this formula. Now, if you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. And now we turn to prisms. First, we will look at rectangular prisms. Those are like boxes and so on. Firstly, we will look at a cube. This is the transparent version. So that is a cube. If you take this cube and stretch it out like that, the ends will still be squares, but these sides will now be extended. So you get something that looks like this. And this is called a cuboid, which is cube-like. This is the transparent version. And then if you take this cuboid and stretch it out that way, then this square no longer remains a square, and you get a shape like this. So that all the measurements, length, breadth, and height, are different. This is called a rectangular prism. This is the transparent version. So please note that a cuboid is a kind of rectangular prism, and a cube is a type of cuboid. With all of them, we will use basically the same formula.